Hey guys, this is Cole with Regal Metalworks. Hey, I just wanted to give you guys a little update here. I know I said I would about when I finally got this welding positioner retrofitted with a proper motor instead of using a drill. So what I came up with is running a motor here with a gear head on it, so it's gear reduction. And these guys are hard to find depending on the application you want, and they can be pretty expensive too. But what I ended up going with was a wheelchair motor, a used wheelchair motor, to prove my theory out here. I found it on eBay. I think it was like $25 with free shipping. And then I went ahead and retrofitted and made this coupler here that joins the where the drill would normally connect on that shaft to this particular shaft. And I actually have a sample of how I did that. So on this motor, here's an identical motor. You can see it has just a round shaft. There's no keyway or flat, and it does have a pin slot there. So I went ahead and just pinned that slot with a bolt and nut. That's what I did here, as you can see. Pretty simple, nothing too terribly difficult. And on the other side, here's one that I made up that I machined here at first. You can see that's just round there, it fits right in, the pin just drops in. And then on this side I just machined out a, originally I did a 5-sided and it turns out it's a 6-sided. I don't know, for whatever reason I didn't count it right. So I remachined it and it works, but it's not the prettiest, so I just started over and made a whole new one, so it was real tight. And then I just put a set screw, just drilled and tapped and put in a set screw to make sure that it won't pop off or move, which it doesn't. And then I went ahead and made a bracket here. We bent this bracket out and bolted it back to the back half of the chassis here. Normally you would mount this motor, you would use these 3 mounting screws, or I should show you here, these 3 mounting screws, but that really wouldn't work well for me, mainly because this part is stationary and this part pivots and the whole motor needs to pivot. So I found the best place to really mount it was back here, so that when I tilted it down, this would all clear. And you can see I left enough room here on this bracket that it would clear over that. And I can show you here. There's that guy. All right, we're going to show you how this pivots. And you can see here, pull out my little pin here, this whole thing moves. So my motor moves with it and stays stationary. We clear this stationary outside frame with the interior frame. And we have no problems with clearance or how that, it doesn't bind the motor up on the shaft or anything like that. So you can mount it either horizontally or vertically and you have no issues. And this, I went with a cheap 12-volt converter. So these are 12-volt batteries. You can run on 24 volts if you need to. Most wheelchairs will run 24 volts, even 48 volts if you want to push it. You will build more heat up in the motor, but for what these are being used for, that's light load, there's not a lot of demand on the motor, it wouldn't be a problem. And how these motors work is this regulates the voltage, so it's a DC motor, it's not an AC motor, it's only 12 volts. So as you lower the voltage, which is what this does, it actually will slow the motor down. So if you get to your maximum speed, full bore all out, and it's not fast enough, you have to go with more voltage, so you'd have to step it up. Now I'm running currently this system on 12 volts, which is very economical. There's cheap regulators, voltage regulators that will do both forward and reverse. This one only does one direction, unfortunately. And then I'm using a 12-volt power supply that we have over here. This 12-volt power supply I'm using, it's kind of big. I think I got this off of Amazon. It was like 35 bucks. It will supply more current than I really need for that particular motor, but you're better off having more current than less. Although if your voltage regulator is underrated, you will burn that up. And I have tested that. I had a smaller regulator that I tried to run with this motor that's over here, this guy, and I used this actually on my other one that had a smaller motor on it. And this did forward and reverse, which was really nice, but I actually smoked it. But that's cheap. They're only like $8 or something off of eBay. Same thing with this. I think this was maybe $12, but you can buy
ones that do both voltage, both directions, so it actually reverses the voltage. So that's all you're doing is reversing the polarity on this particular motor. Now on the input of these, you can't reverse the polarity coming into it, or you will burn these up. The diode and the where the power comes in will actually smoke, which you can fix, but for the price, it's not worth the hassle. So I just have this wired up to a switch here, and this basically just allows the AC voltage, because this just plugs into your 120 or 240, depending on what you have, 220, and that turns on the power there, which powers up this 12 volt supply. And I have a lead coming over to my controller here, and then this powers up this guy. So now I can actually spin. You can see it spinning. Now this is 0 gear reduction right here. See how fast that's spinning? So something like this has a dual shaft, so you can actually put something on this where you can manually spin this if you wanted to, if you were doing something, you know. I have a use for this particular motor where I'll show you that in a little bit, where I plan to use that for a manual spin. But you can see the gear reduction here. I think this motor is somewhere around 55 RPM at full 12 volts. So that's actually going about approximately 55 RPM revolutions per minute. And this has a gear reduction, I think 40 to 1 is what I said in my last video. So that's even reducing that down even lower. And what we have here is the max spin speed that we have up here on our carousel. Now I found, welding my piece for another product that I'm going to show you here in a little bit. This guy, excuse the magnets, this feller, which is pretty small, that almost full bore is about as slow as I can weld with it. So about right there. And it's about my max speed for welding, and it's pushing it. It's I would like to have a little bit more top end on it, and I don't have it. So that's why I was mentioning earlier, where I might need to go get a 24 volt power supply so that I have more headroom on the controller. I have some video footage of the welding done on this when I did some previous welding on this. And this is a product that I'm bringing to market here before Christmas. It will be available. This is an armrest for welding, and it's actually, you can use it for welding on a turntable. So here's a prototype of the product, and this is actually what I'm welding up here using this turntable, and this is your armrest right here that I use to hold the torch. With my arm on this armrest to hold the torch right there, and I can put my other arm in there to add the filler and not have to hold it out in open space and have any movement, as you can see, because, well, it's a little shaky, of course. And what I came up with is this completely articulating armrest here that also doubles as a torch holder. And we'll do an in-depth review on this product. This here is a prototype. I actually have 50 of these completed. They just need fully assembled, and I'll show you what I have over there. But this prototype here was been tested all summer. I've been using it on pretty much anything that I've welded that's been an odd shape or, you know, gets a bit too hot to really prop your arms on, even with, you know, the infamous TIG finger, which is a fantastic product for what it is and really can bail you out in a pinch. This allows you to get off the product altogether. And it's constructed out of stainless steel, aircraft grade aluminum, 6061 T6511, steel base. This is all 1/4-inch plate steel, and of course steel block, and that's all welded together. Now in this here, it's part of these are prototypes and part of its final product. This base is all a prototype. This is a prototype, but a final product version of anodized red and black. The actual colors I'll show you over here, what I went with, are actually silver and black. So I did the body in silver or black, and I did the knobs in silver. And this is all machined and made in-house. The only thing that is outsourced is this cam lock lever, and of course the bolts, and the base piece, the two base pieces. This piece here I made in-house, but because of the amount of difficulty it is to plasma cut holes like that, I have it actually laser cut for me so that everything's perfect and perfectly aligned. But this piece here was made in-house. First, here's parts that I machined in-house. This is all 1018 steel, 1x1 block that gets basically drilled and bored 755 inches, 0.755 inches, so that we have enough room for the 0.75 inch stainless steel rod to slide in with very little slop. And then it is drilled on both for a set pin and for the mounting screw, the pivot block. And then these are actually sent out, and these are nickel plated. Because this is a wear item that moves, I wanted to actually have a finish on there that wasn't going to wear off, and nickel plating was my best option I came up with. Powder coating would have wore, plus it would add some millimeters of thickness, some mils actually, as they would call it, I think 6 to 8 mil thick, which would start to cause some interference issues because this piece actually moves. All right, here we have, this is actually a production unit here. This is basically assembled and completed and how they're going to be offered to the customer. And let me do this out. We're kind of in stages of pre-production here, or actually assembly, pre-assembly. You can see some of the pieces are laid out. The bases here are all nickel plated, so that avoids rust, and it also gives you a nice appearance without having to do, like I said, powder coat. And I'll show you why I didn't want to do powder coat. So this piece here has a set pin in here, and then we use a bolt that has a sleeve on it, and that sleeve allows us to pivot. So when we pull this pin out, like such, this now pivots. Right? So powder coat between here on this particular, the frame, base frame, and this pivot block would wear and cause premature wearing of the finish, not to mention it would start to bind up in there. And one of my beta pieces that I was testing, I didn't have any finish on here, and all I had, it was bolted together. I had nothing in between there. It was just metal on metal, and it worked fine for a while until we got to the point where grinding and dust particles and whatnot would get down in there, and it actually started to bind up, and it actually started to tear this metal. And it looked pretty bad, and so I always knew I was probably going to have to go with a bushing or a bearing, but a bearing would just add too much cost. Another product to add into this, so I went with bronze, oil impregnated bronze bushings, and that's why you see here that these are pocketed. So I actually pocket these out on the CNC mill, and you can see one here, it has a bushing pressed into it. A little better there. There you go. And this adds the lubricity that you need for that to allow the pivot block, which I don't have any sitting out here, to ride on that. So this actually spins on that, and it doesn't rub on your steel, between the two steels. So this is the actual shoulder screw that we're using, and here's the bronze bushings, and you can see there are two different sizes. The one size allows it to fit over here, and then we have a smaller size that fits here. And basically our pivot block, it sits exactly in between the two of those. And when you tighten this down into the two halves, you put pressure on these bronze oil impregnated bushings, and you can go ahead and pivot that to your heart's content, and you're not going to have any binding. All right, here we have the main body, and you can see here that it rotates 360 degrees. It's on a 12-inch shaft, long shaft by 3/4 inch, and you can actually turn this upside down if you need to get a couple extra 2 inches height, which has proved to be useful in a couple of instances for myself. This also pivots 360 degrees in 2.4 degree increments by the teeth here. These teeth grab when you tighten it down, and that moves every 2.4 degrees. So it gives you a lot of flexibility into where you want to place this thing. And then we use an 18-inch solid stainless steel shaft that's 3/4 inch as well. So that allows you to pivot that, move that however you need. And of course, this guy angles. When you pull this out, this angles. And then you have a few different slots here, so you can angle it directly off the table, straight down. You can actually put it back to here and then use this pinhole to actually lock the whole assembly out of the way. And then you have your torch holder right here so you can place your torch. And this will fit pretty much any torch you got, any TIG torch at least. This allows you, if you can even go forward, allows you to reach over the table a little bit. This allows you to go back here off the table and directly underneath. And this is if you clamp this on the table. I've already used this on a car underneath to weld an oil pan, clipped it on the A-arm, flipped this around, and I mean, it's super versatile. You see there's quite a few we already have pre-assembled. We're waiting for cam locks, or there's more of those I got to order. Those ones, believe it or not, those pieces are the most expensive part to this whole entire thing. I mean, that I have to shell out monetarily wise, besides the base pieces, getting them or laser cut. These guys are pretty solid, but we went with a solid aluminum arm, and we also went with an adjustable arm. Some of the cheaper ones don't allow you to adjust that. That way you can always put that wherever you want. If you want to use this as a right-handed, you can put it on the right side. If you want to use it as a left-handed, you can flip this whole body over and use it as left-handed, and then you can readjust where you actually pinch it down, where it will actually lock down. So how much torque you want to tighten. So if you loosen that and tighten out a little bit and push it down, it'll become even tighter. We went with the normal pinch and slot here, where as you tighten it down, it just pinches that whole thing, so you get that whole surface area is engaged into this. Where originally I tried a set screw like I'm doing here, where this is not as crucial, but the set screw, digging into that, you could just not get it tight enough to where when you lean this out and put pressure down on it, it would just kind of fall away from you. So this works exceptionally well. Here's our main block here, set screw block. This is actually down here. That allows you to crank this up. And this foot is a swivel foot, and it's adjustable to different planes. So if you have something that's not quite, flat, like you're pinching on an A-arm on a car or something to weld off of, this will adjust for that. Now this design here is basically set to do anywhere from like an 1/8 inch to, I think, right about an inch is the maximum you can get throat-wise on your table. I have a design for a little wider one. It's actually sitting here. I actually made it for my table. When I originally designed it, my table was 1.3 inches. I thought it was 1.25 inches, and actually didn't make it big enough. I'm not sure which ones are the wider ones. But the problem with the wider ones is you can't clamp it down like on a 1/4 inch table, but these standard bases work with everything. I do have other bases already designed. I don't have them made yet that do for tube clamping and also for clamping on the tab and slot style tables that have the holes in it. So you don't have to clamp it down. Some of them have front fascias that have holes on it. It doesn't basically have a bottom. It has another thing here where you actually set a set pin in there and it locks the base in. I have them designed for, like, I believe, 2 different style tables. I just do not have them produced yet. I also have a base that will allow you to clamp onto tubing. So if you're doing like a tube chassis car, or you're doing like a roll bar inside of a car, you can clamp to that and position this wherever you need to make your welds. So it's pretty much modular. Everything's replaceable. I have other designs for other articulating arms that will easily come off and go on. So there'll be a lot of accessories available for this in the near future. This monster here is a 30-ton
press brake. It's a mechanical flywheel press brake that I just had found, believe it or not, on Facebook Marketplace just about a month ago. She weighs somewhere over 4,000 pounds. It was enough that it pushed my forklift to its limits. When I tried to pick it up, it actually tilted the forklift. And my forklift is rated at 3,900 pounds, but we were picking it up at the top point here, so it actually, you have to pick it up from the bottom point. But yeah, this is a new product, or a new tool that we got, that I added, that we got a really good deal on it. A guy, it was mostly sheet metal work that he did. He had quite a few presses. It's 220 volt 3-phase, so I had to install my phase converter because I don't have 3-phase here yet. In this setup here, how these flywheels work are different than hydraulic presses. Hydraulic presses have 2 arms that press down, and you can press it down and back it off as you need with like 2 separate pedals. With these have a full stroke, so the flywheel that's in here spins around, and it has a slipper clutch back here. Here's our slipper clutch. So this actually slips. So until you actually step on that lever and then put pressure and engage this, it's not, this ram is not engaged. So once you engage that, this ram wants to go full cycle. So if you do a partial step down, it'll bring it down, 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 down until it hits the bottom of the cycle, and then it'll want to go back up. So the problem with these is you're committed to what you step into. You can't stop and back it out. The only way you can do that is to actually shut the machine down, let the flywheel stop, come to a full stop, put it in reverse, and then you can back it off. So you can't really do setups real easy. So how you have to do your setup to get the upper die and the lower die correct is you actually have to manually adjust. As you can see, this is spinning right here. Let me see if I can get in a little bit better. When I dial this in, it spins very slowly. Still not focused. There we go. It spins very slowly, and you're having to crank it quite a bit. And this will raise and lower the ram here so that you can set the full stroke on your die here, so that you can, figure out your degrees you want to bend, if you want to, bend to 90 or slightly more or less. And of course, this will take any 1/2 inch American die. And the problem with this, that it spins so slow, is I want to put a motor on it. So this is where I was going to use that other motor. So I was going to do a 12 volt with a forward and reverse using that same motor, so that I can actually just push a button and this will actually lower it and get it down to where it's at. Because right now, if I have to come way off, I mean, it could take me 5 minutes spinning that thing, and your shoulder will feel it. So that motor had a dual spindle on it, so it actually had a flat slide. So I can actually put a wheel on it, so I can actually fine tune it if I didn't want to, if I only had to go a little bit and I didn't want to engage that, I can actually just manually spin it, which would be the same as doing this here. So that was the goal of using that other motor that I was talking about earlier that I wanted to show you. But I also wanted to show you this 30-ton press brake that we got, Chicago, dries and crump. They just don't build them like this anymore. Everything is hydraulic now. You don't have any of the mechanical flywheel. They definitely have their uses. They do have their drawbacks, but they're affordable. You can get them if you can find them. I think eBay, they go for around 6,000 to 10,000, depending on the size. This is a 6-foot jaw, so you can put in a full 6-foot die. I have a bunch of, I don't know where we put them. I had a bunch of dies. Yeah, I think I have like maybe a 4.5-foot lower die and a bunch of small finger dies that I can put in there. You can also, because it's a 1/2 inch, you can actually use the Swag off-road finger dies that I have, like these. So all those dies would fit in there. They would work as well. But we installed our 3-phase converter to run this. And it's a 20 amp. You can see I ran my power all the way up. Let's see that. All the way up over here. We ran 10 gauge wire to it. And I actually installed American Rotary 20 horsepower over here. And here it is here. We got that in the controller.
And the reason why I installed it here, I really kind of wanted it to have it closer over there. But you need to run twice the gauge wire that you normally would run to power feed. So I actually have 4 gauge wire running to this, and then I have 10 gauge running out. So I would have had to run 4 gauge the whole ways up and over to there to actually put the converter over there, which is kind of cost prohibitive. But it's all wired up, and you basically would turn it into run, then you hit start. And it kicks that motor on, and that's generating your third leg, the third phase of your 220. Or in this case, 240, because I have 240 coming in. And then shut it off and just shut it off. Also want to give a shout out to all the new subs on YouTube, 329. Really appreciate that. I know it's been a while since I've done some videos, but it looks like turn of the year I'm going to be doing more work here, so I'm going to probably have a lot more content that I'll be able to put up for you guys, and hopefully some more instructionals. It seems like I'm getting more views for some of the instructional stuff instead of just the daily vlogs, but we'll mix and match. We'll put a couple of those up one way or the other so that you guys can see what's going on. Hopefully this next year there'll be a lot of good stuff going on. That new product, when that hits, I have some other ideas that will hopefully, you know, bring some more subs and, you know, bring some more, you know, business to our doorstep here. So, alrighty guys, that's about all I got. I gotta get out of here for the evening. Have a good one. Peace out.